Okay, welcome to Math 158, Functions, Graphs, and Matrices. This is section 3.3, Annuities, Loans, and Bonds. There are several different topics in this unit, in this section that I want to cover, so I'm actually going to do it in two parts. So this is going to be mostly focused on just the annuities. We'll save the loans and bonds for part two. So first of all, what an annuity is an annuity is basically a financial instrument that requires a series of payments of set size and frequency. Okay, so the annuity might be, if you think about somebody who wins $20 million in the lottery, boy, I wish that was me. Somebody wins $20 million in the lottery, they don't get $20 million. The state doesn't have, the lottery doesn't have $20 million. What they have is they have some money sitting in an account that's earning interest, but then every year that winner may get $1 million once a year for 20 years. When you retire, you may have an annuity that pays you, $5,000 a month for your income. That'd be a nice retirement income that you get just every single month. This is how much money comes in. That would be when you're receiving money from an annuity. However, what you may do is invest in an annuity by investing your interest, say, monthly, or by making your investment monthly. In the previous video, section 3.2, on compound interest, all the conversation was around, suppose I invest $5,000 into an account, assuming I invest $1,500 into an account, and I just let it sit there and grow. That'd be really nice if I had, I'm 20 years old and I've got $15,000 and I'm going to set it into an investment and let it grow over the next 40, 50 years, and what will it be? And that's really interesting to know, and that's what we did in section 3.2, compound interest. What we're going to do in this video, though, is we're going to look more at how I say most people invest, which is I'm going to, on every payday, I'm going to invest $50, and I'm going to put $50 into the account. And the next payday, I'm going to put in another $50 and another $50, or maybe it's $100. Okay, and so it's that type of investing. In this video, both part one and part two in this section, I'm going to show you the formulas. However, I am not going to require in any of my courses that you compute the solutions using the formulas. In the previous video, I walked through how to use the TVM solver, and in this video, I'm going to use the TVM solver on the graphing calculator. The TVM solver, as I mentioned in the previous video, works similarly. If you download a TVM solver for your phone, you find one online, it'll work that way. But here's the formula. So let's talk about it just briefly. The first version here, FV equals PMT times 1 plus I to the n minus 1 divided by I. That I is equal to interest rate divided by number of times that you're compounding. Okay, so in that case, I like to just use R over N. Okay, the other thing in this, so that I like to use the R over N, and that's what I'm going to use. And so the version of the formula that I'm going to be referring to is this version here, FV equals payment times 1 plus R over N to the NT minus 1 divided by R over N. Now, I may make a separate video deriving that formula. If we were in class in person, I would probably want to at least walk you through the concept of that formula in a little bit greater depth than I'm going to do here. But let me just show you briefly the concept that the math develops that results in this formula. Let's suppose that each month you're going to invest $100. Okay, forgive me for that. Each month you're going to invest $100. So I'm going to invest $100, and let's suppose I'm going to get 6% interest compounded monthly, right? So I'm going to invest $100, 1 plus 0.06 over 12, and let's just say that I'm going to invest this for 30 years. So that would be 360 months. The next investment, the next month's deposit, I'm going to put into that account, and it's going to earn 6% interest compounded monthly, but it's not going to be there for 360 months, because if I'm planning to retire in 30 years, how much money will I have in my account at the end of 30 years? This amount will only be there for 359 months. The next investment, the next payment, will only be there for 358 months, and so on and so on and so on. So obviously the first monthly payment will be the one that develops the most. You go do some really crazy fun math. to derive the formula, and the result of that is this formula. Now for Math 158, it's not nearly as important to me that you can derive the formula. It's much more important that you can use the formula, and more importantly, that you can use the graphing calculator. Okay? Number one, at the end of each month, you invest $50 into an account earning 2% interest compounded monthly. What is the value of your account after 5 years? Now, I will do this one using the formula, but probably only this one. At the end of each month, you can invest $50. And the question is, what's the value of your account after 5 years? So we're computing the future value. Okay? The future value is what I need to figure out. And so FV will equal my payment, which is $50, times 1 plus my interest rate, 0.02. It's compounded monthly, so over 12, to the 12 times 5 minus 1, all divided by the 0.02 over 12. I don't think anyone is going to go and do that without using a calculator at all. Okay? You're going to use the calculator to do the computations, probably similar to this. 50 times, and I'm going to do another parenthesis, 1, actually let's back up. Let's go a little bit slower. Let's do the 1 plus 0.02 over 12. That's what's inside the inner parentheses, enter. To the 12 times 5 is 60th power minus 1. And so that's my numerator right here. And I'm going to divide that by, let's put parentheses around this, 0.02 over 12. And now that 63.04 is this amount right here. And we're going to multiply that by 50. So at the end of my 5 years, by investing $50 a month, I have $3,152.37. Okay, so I can do that, and calculating the payment is actually not too bad. Calculating the R or the T, that becomes a lot more cumbersome. But let's go to the app. Apps, Finance, TVM Solver. Okay, what do we do? We're going to invest $50. Now this time we're investing $50. These are our payments. We're making a regular payment of $50 into our account. And we're going to do that each month. Now this is different than last time. Our PY and our CY are both relevant now. PY is payments per year, compoundings, or CY is compoundings per year. So notice at the end of each month, we're investing $50, so our PY should be 12. And my interest is compounded monthly. It's really nice when those match up the same. So my PY and CY should both be 12. We're making monthly payments of $50 into an account earning 2% interest compounded monthly for 5 years. 12 months a year for 5 years. Enter. And now we're going to calculate our future value. Notice it's the exact same number, 3152.37. Okay, so I'm going to do the rest of this using the TVM solver. Suppose that I invest $200 a month, into an account earning 4.2% interest compounded monthly. What will my account be worth after 10 years? 120 months. So we're now going to go calculate our future value. $29,762.62. Now, something that's dangerous about this in a math class on a math test is if I use the TVM solver, what do you show me for work, right? If you're taking a test on this, what I would suggest, if you're concerned, that you write what you put into the TVM solver. N is 120, the I percent is 4.2, present value is 0, payment equals 200, PY and CY are both 12. And if you do that, and the future value is what you're solving for, if you do that, then that's showing me work. That's showing whoever you're taking the course with some work that you can do there. I want to believe that you're doing this with a TVM solver. And so I'm, from now on in this video, I'm going to do the work on the calculator and put the answer on the paper. So if you need to, hey, what did he do here? You're not going to see work on the paper. Just back up the video and watch me do it again. So in number 3, how long will it take for this account to be worth $50,000? Now, let's assume I wasn't clear here. Let's assume I mean this $200 account. If I'm investing $200 a month into an account earning 4.2% interest, after 10 years, my account is worth $29,762. Well, how long will it take to get up to $50,000? So negative 50. Remember that future value is negative because the TVM solver is going to think that I'm putting the money in, which is why my payment is positive. And at the end of the time frame, I'm going to take my money back out, and I'm going to deduct it from my account, which is why the FV is negative. And the question is now going to be, how long? It's going to take 179.9. Now be careful. My PY, my CY are both months, so this is months. If you want to know years, then you're going to need to divide that 179.9 by 12. And that would be 14.99 or 15 years. Okay, so with the TVM solver makes this very nice as long as you're paying attention to what you're doing. Okay, now those examples that I was just talking about were assuming that you're starting with 0, right? So far, previous video, we talked about we're going to put money into an account. Let's just put in $1,000 into an account and let it sit there over time. The problems I just did, we're not starting with money in the account. We're starting with 0 and just investing $50 or $100 every month. It doesn't take very long till we say, okay, let's go forward here and say what we're going to do is, what if we start with a value that's not 0? Like look at example number 4 here. My retirement account already has $5,000 in it, or I put $5,000 into an account. It's earning 5% interest, and then what I'm going to do is I'm going to, in addition to putting in the $5,000, I'm also going to add another $100 per month. And what you'll notice in this future value formula is that the first part is the formula we used last time, present value, but the payment was 0. So this latter part was not here. In the previous examples, all we did was payment because our present value was 0. Well, if the present value and the payment are both not 0, then we're going to use both parts of the formula. And again, I get it. This formula, as much as I enjoy formulas, I really don't feel like crunching that formula every time. I'm not going to. I'm not going to demand that you do it either. But I am going to demand that you can use the calculator, the TVM solver. So the only difference here is that my present value and my payment will both not be 0. Okay, so my account has $5,000. It earns 5% interest per year, compounded monthly. So my CY is still 12. At the end of every month for the next 10 years, so my N is 120 months, I'm going to add $100 to my account. $5,000 to start, $100 added monthly. I'm adding it monthly. My interest rate is compounded monthly. My 5% is compounded monthly, 120 months. Now we want to compute our future value. The future value of that account will be $23,763.28. Okay, TVM solver makes it really nice. I suppose I could say that over and over. What if I started with $7,000 and then I contribute $50 a month into an account earning 5.5% interest per month, right? Compounded monthly. So my PY and CY are both monthly. How much will my account be worth in 15 years? Well, 12 months. 15 years is 180 months. Make sure everything else is there. And now we're going to calculate the future value. So if I invest $7,000 and then $50 a month, after 50 years at 5.5% interest, my account will be worth $29,880.36. So I just have a couple more pages that are, problems that are variations on that. Okay, and this question I'm going to ask in a lot of different ways. We want to be able to handle this from a lot of different directions. Okay, so let's talk about Bob. Bob is currently 35 years and hopes to retire at age 65. Unfortunately, Bob has not yet begun to invest for his retirement. How old is Bob? Bob is 35 and he hopes to retire at age 65. He's going to make an initial deposit of $10,000, so that's the present value, into an account paying 8.3% interest, compounded monthly. What will Bob's account be worth in 30 years? Now notice, Bob is not making additional payments, so the payment is zero. And he is going to invest 12 months for 30 years. What will his account be worth in 30 years? His account will be worth $119,583.32. Now, I did tell you a few moments ago that with the TVM solver, this is nice. I don't have a lot of computation to do. I will tell you that myself, I'm not real forgiving when it comes to computational errors, because there really aren't any computational errors to make. So if you told me it's 31 cents, you're only off by a penny, but it should round to 32. So make sure that you round correctly. All right, let's keep talking about Bob. Unfortunately, Bob does not have $10,000 to deposit. What 35-year-old actually has $10,000 just sitting around, okay? It happens, not frequently. So he doesn't have the $10,000 to deposit into the account paying 8.3% interest compounded monthly. Instead of making that initial payment, what he's going to do is say, I don't have $10,000, but I have $75 a month. What if I do that instead? Now, that's the only thing that's going to change, because his payments are monthly, his 8.3% is still compounded monthly, and it's still for 30 years. Now, what would be the future value of his account? His account will be worth $118,825.28. So notice there's some life lessons in here. And if you're going into finance, some good things to know. He's only $700 behind where he would have been. Okay. Now here's the difference though. In example A, notice that Bob's total investment was $10,000, right? His total investment was that $10,000 up there. In example 1B, what was his total investment? Well, he invested, I'm just going to do the math here, $75 a month every month for 360 months. So his total investment was a little bit more. It was a $27,000 investment as opposed to a $10,000 investment, but still got him to the same retirement goal. Okay, I like asking questions like question E. Which option is better and why? It really is not a this option is better for everyone or that option is better for everyone. Clearly, the $10,000 investment is the better choice if Bob has the $10,000. If Bob doesn't have the $10,000, then the $75 investment is the better option. Now, best of both worlds. What if Bob's got $10,000 and $75 a month and he does both? Then his total investment at that time would be the sum of each of those two numbers. Okay. So the option, especially those of you that are going to be financial advisors, when you're learning your client, you need to know them, their circumstance. Okay. So here's what Bob's going to do. He says, okay, I don't have the full 10 grand, and I'm going to do a little bit about both worlds here. So he's going to choose to invest $5,000 into the account, and he's going to make monthly payments of $100. Still at 8.3% interest, compounded monthly. His payments are monthly, and for 30 years. His future value then will be $218,225.37. It's not a bad deal. Okay, not a bad deal at all. A couple more problems and then we'll finish this part here. Number 7. This is not Bob anymore. We've moved on from Bob. We'll visit Bob in the next part, I believe. Assuming an account will earn an annual rate of 8% interest compounded monthly, how long would it take for an account to grow to $250,000 if $300 contributions are made monthly? Okay, so it doesn't say we're starting with money, so we're going to assume that our present value is 0. We're going to earn, we think, 8% interest compounded monthly, so our CY is 12. We're going to make monthly contributions of 300, but we want our account to grow to $250,000. Don't forget to put the negative. And the question is, how long? Alpha. Solve. It's going to take 282.9. Let's just call that 283 months. And again, if we want to know years, we would divide that by 12, and that's 23.6 years. Leave it 0.6 years. Don't try to change it to months, because remember, there are 12 months in a year and not 10, and so the decimal does not translate simply. Okay. Assuming that an account will earn 8% interest compounded monthly, so it's the same scenario, 8% interest compounded monthly. How much should be contributed monthly if I want that account to be $250,000, $250,000 in 20 years? See, this is going to take me 24 years. I don't want to take 24 years. I want my investment to be worth $250,000 in 20 years. 20 times 12 is 240 months. This means I'm going to have to invest a little bit more. So let's compute the payment. So if I up my monthly contributions to $424.43, I'd probably make it $424.50. Okay, if I invest $424.43 a month, then my investment will be worth $250,000 in 20 years, not in 23 and a half years. Okay, gets me there a little bit quicker. Last question for this section, for this part. An investor hopes to increase his retirement account to $950,000 by the time that he retires 10 years from now. The present value of the account, let's just go right here, the present value of the account is $250,259.12. So he currently has $250,259.12. Don't worry about, but he's not putting into the account right now, it's already there. Same thing, okay? So he's got a present value of $250,259.12. He expects that his investment, I want to know where he's investing. He's expecting his investment is going to grow at 13.16% interest compounded monthly. In order to reach his goal of $950,000 within 10 years when he retires, 12 months, 10 years, what must his monthly contributions be? So we've got everything else in there, and now we're going to go to the monthly payment and solve that. Okay? So he would need to invest $95.69. Of course, if I was him, I'd probably just throw in $100, and I'll exceed my goal of $950,000. Okay? So there's a look at using the TVM solver mostly, but how do I compute if I make not just a lump sum investment at the beginning of a time period, let my money sit there for, say, 10, 20, 30 years, but I maybe put some money in there, but I also contribute $100 a month, okay? And that's really the most effective way to invest, because putting down a nest egg of $10,000, $20,000 is not something everyone can do. Starting to invest at $50, $75, $100 a month is something that most people really should be able to do. Okay, so work on some practice problems with that, and be sure to watch section 2, part 2 of this video, and we'll get into loans.